Greetings, viewers. Once again, I want to welcome you to this YouTube class, and I'm excited that you are here. So, in today's class, we're going to quickly look at an important parasite that affects man or that infects man, and that parasite is a parasite under Platyhelminthes, and not just under Platyhelminthes, but under the cystoda or the tapeworms. Don't forget that there are two classes of tapeworms, sorry, of Platyhelminthes that we discussed in the past, the Trematoda and the Cystoda. And we further discuss Cystoda or the tapeworm and mention the two important orders that are found there, the Cyclophilidia and the Pseudophilidia. Under the Cyclophilidia, I know I did mention the Echinococcus granulosus, the Taenia cilium, Taenia saginata, and Hymenoplepis nana. Apart from these four that I've mentioned, coming to the other class, so the other order, sorry, of medical importance, which I thought about is Pseudophilidia. You know, there's Cyclophilidia and Pseudophilidia. Cyclophilidia, then pseudophilidia. So these four that I mentioned, the Taenia cilium, the Taenia saginata, Echinococcus granulosus, and Hymenoplepis nana are under this order Cyclophilidia, whereas Diphyllobothrium latum and Spirometra and other are under the order Pseudophilidia. Now, it's important you understand that Diphyllobothrium latum is the largest tapeworm that infects man. And of course, man is a definitive host with other canids such as dog and wolves. Man is the main definitive host, then followed by dogs and wolves and the rest of them. So the size of this parasite is about 2 to 10 meters long. 2 to 10 meters long. Sometimes we'll have some members that even get to 15 meters long. You can see how big this parasite is. Diphyllobothrium latum. Sorry. The few of the characteristics is the fact that there is presence of two oral growths that is known as botria. Now, if you look at this parasite is not does not have the globular head as you see the globular head as you see in members of Pseudophilidia. Instead, by the two sides, it has two oral growths that are called botria, and this is how it appears, the botria. And of course, they don't have hooks. It is this botria or the two oral stalkers that does the function that perform the function of hooks, as you can see in members of Cyclophilidia. As you know already in other tapeworms, this parasite is hermaphroditic. That means that the male and female sex organs are found in a single organism. Then they have three different types of larvae, which I want to mention now. They actually produce three different types of larvae. The first larva is what they call the coracidium. They have a larva called coracidium. They have the one called prosarcoid. They have the one called pleurosarcoid. So these are the three types of larvae that you can see in uh, Diphyllobothrium latum. The coracidium, prosarcoid, pleurosarcoid. This is the immature larva, the mature larva. I'll still mention this by the time we come to the life cycle. Then when it comes to kingdom, the kingdom of course is Animalia. Animalia. Then the phylum, of course, is Platyhelminthes. I'm doing the classification now. Then the class is Cystoda. Then the order is Pseudophilidia. The order is Pseudophilidia. Then the family is Diphyllobothria. Then genus is Diphyllobothrium. Then the species is latum. So this is how to classify Diphyllobothrium latum. Diphyllobothrium latum. I hope you can see all this. This is Pseudophilidia. Let me rewrite it in case you can't see it. Pseudophilidia. Pseudophilidia. Then Diphyllobothria is a family. Diphyllobothria. Then of course Platyhelminthes is popular. Cystoda is the class. Cystoda. Okay. Having known this now, I think it's time to look at the life cycle of this parasite. Going into the life cycle of this parasite, going into the life cycle of Diphyllobothrium latum. Now, it is important you know that Diphyllobothrium latum, completes its life cycle in an aquatic environment, just like the schistosoma. It embodies schistosoma when it comes to its life cycle. So without aquatic environment, the life cycle of the Diphyllobothrium latum cannot be completed. So the life cycle begins uh, by the hatching of the eggs or the parasites. Let me say a defecation. If somebody is suffering from diphyllobothriasis, let me start with that. If somebody is suffering from diphyllobothriasis, diphyllobothriasis, diphyllobothriasis is the name of the disease that it causes. So if someone is suffering from diphyllobothriasis, then of course the person goes into an aquatic environment to swim. Within that aquatic environment, if that person releases, if that person defecates, then you discover that you see the eggs of this parasite within the feces of such individual. So within the feces of such individual, the eggs will be formed there or will be found there. Now, the eggs hatch within aquatic environment. Remember I said, if this individual defecates, probably while swimming in aquatic environment, the eggs hatch within this aquatic environment. And as this egg hatch, they hatch into a larva that is called coracidium. Now, as this coracidium is released into that aquatic environment, then a crustacean or a copod ingests this coracidium. And by the time this coracidium is ingested by a copod, then inside the body of the copod, it's the larva, which is a coracidium, molts or grows or transforms into, that's the correct word, transforms into the next larval stage, which is called the prosacoid, right inside the body of the copod, right inside the body of the copod. The coracidium transforms into another larval stage, which is called the prosacoid. The prosacoid. Don't forget that one of the basic characteristics of Diphyllobothrium latum is the fact that it has two intermediate hosts. One of the intermediate hosts is a crustacean or a copod. Then the second intermediate host is a fish. And that is what I'm about to mention now. This uh, prosaccharide is also ingested by a fish. By a fish. Once a fish ingests this prosaccharide within the body of the fish, the prosaccharide transforms into another larval stage which is called the Prerosaccoid. And this Prerosaccoid becomes the infective stage, or it is the infective stage of Diphyllobothrium latum. Remember, a parasite must make contact with the appropriate host at the appropriate time before a parasitic host relationship can be established. If a parasite does not make contact with the appropriate host, and not just with the appropriate host, but at the appropriate time, then a parasitic host relationship cannot be established. So, in the body of fish, that is when you see this prosacod. Now, it's possible that a larger fish or a bigger fish will ingest this particular fish or feed on this fish, but when it happens, the parasite does not in any way develop into another kind of larva. The reason is because that bigger fish is not the intermediate host. You can call it a paratenic host or a transport host. So it remains within this stage of a plerosaccod until when next the definitive host feeds on that paratenic host. And that is how the cycle will continue. But let's forget about the paratenic host. Let's continue with the second intermediate host that I've thought about. I said the first intermediate host is a copod, the second intermediate host is a fish. So it remains peroxide in this second intermediate host until when next a definitive host ingests or feeds on this fish, then once it happens, the peroxide larva attaches itself within the intestine of the definitive host, and there it stays to grow into maturity. And by the time it grows into maturity, then of course it begins to lay eggs. These eggs, sorry, these eggs that are laid, pass out to the external environment through the feces of the individual. Because of course, as they lay eggs, the eggs are also released into the intestine. And when that individual is passing out feces, then the eggs leave the body of the individual through the feces into the external environment. And if that environment is an aquatic environment, the cycle continues. But if it is not an aquatic environment, of course, the cycle will be truncated because the aquatic environment is necessary for the completion of the life cycle of Diphyllobothrium latum. Why is this so? Because the two intermediate hosts that are so important for the completion of the life cycle are found within this aquatic environment, the copod and the fish. I hope you understand the life cycle of Diphyllobothrium latum. So let me see if I can use a kind of drawing. So first of all, release of eggs in aquatic environments. Then these eggs develop into coracidium. Then the coracidium develops into coracidium in aquatic environment, in aquatic environment, let's abbreviate environment. Then ingestion by copod, whereby it transforms into prosaccharide. Let me put that in brackets. Then fish, ingestion by fish, whereby it transforms into peroxacoid. Then ingestion of fish by definitive host. Then attaches the larva which is prostacord attaches itself to the intestine, then mature into adults, adult worms. Then adult worms release egg. So this is adult worms. So let me rewrite this. Attaches to the intestine. Okay. So that is it. So release of eggs in aquatic environment. Then the eggs, once they're released, they hatch into coracidium in aquatic environment. Then of course this is followed by the injection of the coracidium by copod, and in the body of copod, the coracidium transforms into a prosacoid. Then fish ingests the prosacoid. Sorry, a fish ingests the copod. Fish ingests the copod. Then I don't know if this was what I said before. If it's not, then this is the correct thing. Fish ingests the copod. Then in the body of the fish, this prosacoid, which is of course already contained in the copod, now is released in the body of fish and transforms into peroxacoid. Then injection of fish by definitive host. The definitive host, of course, ingests the fish, and once the fish is ingested, the peroxacoid now attaches itself to the intestine of the host, where they now mature into adults. And of course, when they mature into adults, they begin to lay eggs, which of course pass out through the feces to the external environment, and the cycle continues. And like I said, if the definitive host does not defecate in aquatic environment, then the life cycle of this parasite will be truncated. But if it defecates in aquatic environment, then of course the life cycle is repeated. Okay, then the next thing now to talk about is the diagnosis. Diagnosis is simple through the demonstration of the presence of eggs or proglottids in fecal sample. So the individual who is suffering from diphyllobothriasis will get the feces, and the lab scientists will now investigate the feces to see if the eggs of Diphyllobothrium or even the proglottids, that is the segments, will be found in the fecal sample. So then we have been told, or we know, that diphyllobothriasis can result to nausea and diarrhea. The individual may begin to experience diarrhea or nausea. Then there could also be mild irritation or inflammation of the intestine from where they use their botria to attach. Of course, they use their botria to attach to the wall of the intestine, from whence they now grow into adult or maturity. So that's point within the intestine where the botria were used to attach to the wall of the intestine, the mucosa of the intestine, may cause irritation of the intestine, can result to injury or even inflammation of that, or even the necrosis, resulting to secondary bacterial infection. That is what happens within that part of the body. Then, Diphyllobothrium has also been implicated in competing with the host for nutritional requirements. So, at the end, we discovered that it can result to B2 deficiency, vitamin B12 deficiency. That is because of the fact that they compete with the host for their nutritional requirements. So as a result of that, the person may have deficiency of a B12 vitamin, and the deficiency of B12 vitamin results to what we call pernicious anemia. Pernicious anemia. Pernicious pernicious anemia. So these are some of the effects, and of course they can also cause abdominal discomfort or abdominal pain. So these are some of the pathological effects of diphyllobothriasis. Then prevention and control. How can you prevent and control this disease? Make sure that your fish is properly cooked. Properly cooked. If it's properly cooked, then it can kill the larva before consumption. And people should also avoid eating raw or undercooked meat. Just like I said, raw meat or undercooked meat should be avoided. Then, of course, uh, public health education, awareness about the disease, about the parasites. If people are aware, they of course know how to possibly prevent this disease. So coming to treatment, praziquantel, niclosamide, praziquantel, praziquantel is okay. One can use this drug, praziquantel, in the treatment. Praziquantel can be used in the treatment of the disease. Then some people use alternative drug, niclosamide. This is an alternative drug, but then praziquantel is the popular drug that is used for treatment of diphyllobothriasis. Diphyllobothriasis. The diphyllobothriasis. Then what again? I think that is all I have to talk about when it comes to Diphyllobothrium latum. The next parasite we're going to be looking at in our next class will be Paragonimus westermani, a long fluke. It's no longer a cystoda, but a fluke. The only two flukes we talked about were schistosoma and fasciola. We omitted the Paragonimus westermani, and I will be presenting that in the next class. Thank you once more for being part of my class. I want to enjoin you or to beg that you share this video to as many that you know that need it, medical students all around Nigeria and beyond that need the study, that needs this study. It will of course go a long way to assist them in their private studies. See you in my next class.